Chapter 2. Beginning of Chapter 2 should be real familiar territory, so I'll kind of buzz along pretty quickly here. Here are the 5 things we're going to try to do today. Learn how, and I know you already probably know these, use slope to graph linear equations in 2 variables. You need to know how to find slopes of lines, not only from looking at equations, but also by just observing a graph. 3, write linear equations. 4, use slope to be able to deal with parallel and perpendicular. And 5, using linear equations to solve problems. So those are the 5 things we'll try to go at. The first slide I just want to show you is a generic view of 2 points, x1, y1, x2, y2. I've shown you those 2 guys before. When we remember when we developed the equation of a circle, and when we also developed the distance formula, we started this way. And the slope is what? Rise over run. It's that vertical change over the horizontal. So it's this guy divided by the change in x. This is the way that's usually expressed. M is used for slope. M equals literally the change in y over the change in x. In fact, you may, in your math class, have learned it as delta y over delta x. Delta sometimes is a shortcut for the difference in y. But anyway, usually we express it this way. y2 minus y1 over x2 minus x1. The biggest sin that I see committed in this formula is people getting the x's on top and the y's on the bottom, and it just throws your results literally upside down. It's not good. So anyway, I'm sure you've seen that formula before, correct? And that thing in the box is the slope formula. Yeah. That's a good question. I think it's French, but it's not real important. Do you remember, maybe you remember this from your previous class, do you remember hearing about mx plus b? It's that same m. And so we are at least being consistent with that. So, again, I'm guessing you've probably had that hammered into your head maybe a little while ago, but I'm sure you've heard that. But that'll be a big one, huge one. Okay, so let's jump in and practice right away. So what I did here is I wrote 2 points up there, and I don't want to just do this, kind of like let's do this together. You could maybe do this on your paper, and then I'll pause a little bit, and then we'll do it up here, and we'll see. Here's the thing. With those 2 points, find the equation of the line. That's the goal. So, given 2 points, find the equation of the line that contains them. And of course, you remember, I'm sure, this old adage, 2 points determine a line. If you have 2 separate points, there's only one possible line that can connect them, right? If you pick another line, it just can't be in a different place. There's only one line that connects 2 points. So let's find that line. Now in the box, lower down, I wrote kind of our goal. Lines, I'd like you to just stick with this. By the way, the book gives you more than one form. They give you the slope-intercept form, which is this one. Slope, intercept, the slope-intercept form. They also give you the point-slope form and the general form. And I have good news for you. I'm going to do everything at this one. I think that's good news because it's just a little easier for you to target things. You only have one goal. So we want our answer to be something like that. What do we do first? Well, what did I just show you on the previous slide? Something about slope, right? Yeah, and that's the first step. Find the slope. So once again, let's just repeat what was on the previous slide. In order to find the slope, do you remember? Hopefully you have a one-slide memory, at least. You have to do this little ratio. So in this case, by the way, it doesn't matter which point you call 1 and which point you call 2. Just don't be schizo and change your mind halfway through. So I'll let you just tell me which point you want to be the first point. Okay, he wants that one to be number 1. Okay, so we'll call this one number 2. So here we go. The slope is equal to the y from point 2 minus the y from point 1. That's supposed to be a 2. I'm already putting the answer down. And on the bottom, we have the x from point 2 minus the x from point 1. Okay, results, 3 minus 2, negative 5 minus 1. So we found out that we have a slope of negative 1/6. All right. Now that we know that, we're going to take this format that we're headed for, and we're going to literally plug in negative 1/6 for m. Excuse me. So all I did is just literally stick it in there in place of m. And now we're almost there. Really, all we got to do is find b and we're done. And somebody in here probably should remember, how do I find b?
Take x and y and plug it into that equation you have right there. Like 3 plus 1 equals negative 1/6. Or 2 equals negative 1/6 plus b, and solve for b.
So he's saying take one of the 2 points that I gave you in the beginning, and it makes sense, you got to go by what's been given. Plug that in. First, the first coordinate in any ordered pair always stands for x. The second coordinate always stands for y. And then you'll be able to solve for b. And that sounds good. And I'll do what he did. Let's take the first point. So in place of y, we're going to put a 2. In place of x, we're going to put a 1, all from right here. And we don't know b, so we just leave that b. Now do a little bit of arithmetic. And then you want to just solve for b. So you're going to want to what? Add 1/6 to both sides. And what? We could either write it as 2 and 1/6, or we could write it as 13/6. It doesn't really matter. Now, come back. Take this line that we have right here and rewrite it, only put the b in there that we just found. So, final equation, negative 1/6 x plus 2 and 1/6, or 13/6. Now we've got the equation of the only line that goes through those 2 points. Question? So this is going to be needed repeatedly. Very important process. So I guess let me just go, what are the steps again? So always find the slope first. Once you find that slope, plug it into the mx plus b formula. And now, you only have one thing missing, and that's your y-intercept, b. In order to find that, simply substitute in one of the given points. Now, sometimes you only have 1 point, and so you will have no choice. This time, we actually had 2 points, and either one would have worked just fine. Some of you may be wondering, what if he had picked this as point 1 and this as point 2? It would have made no difference. The slope still would have come out the same. And here, let's just quick do it. Let's say we reverse those. y2, 2, minus y1, 3. So 2 minus 3, which is a negative 1. And then on the bottom, x2 minus x1. 1 minus a negative 5 is 6. We'd have got negative 1/6. Oh, no big surprise. That's what we got before. So it doesn't matter if you switch those around. And I'm not going to go through it, but it would not have mattered a bit if Trey had said, let's plug in negative 5, 3 instead of 1, 2. We still would have gotten the same. So, okay. Next issue we want to look at. We'll be jumping around, but these are all kind of sample problems, and I'm not spending a lot of time on technique because this is pretty much, I think, review for you. All right, so this time I gave you an equation. In fact, it's the same one we just finished. And this time, I want you to graph it. And I'm assuming everybody remembers how to do this too. So we've got a slope-intercept equation. How can we graph it? What do I do first? So I got two things basically. I got a slope and I got a y-intercept. What can I do first to start getting a graph? Now here we don't want to just pick x and y and make a chart. There's a much more efficient way. Yes? That's right. You want to do that first. And that's your, what does that be? Y-intercept. So where it crosses the y-axis. And we know where it crosses the y-axis at 2 and 1/6. Oh, just a little tiny bit above 2 on our graph. And then, now, obviously, I have to use the slope. Do you remember how to do that? We have a slope of negative 1/6. By the way, general principles of slope. What kind of a slope is a horizontal line? It's got a value of 0. Kind of like saying there is no slope. So 0 slope looks like this. In general, slopes that go uphill from left to right are positive, and slopes that go downhill from left to right are negative. So, oh, I know one more. A vertical line. The problem is the denominator, the x2 minus x1 is going to be 0, and you can't divide by it. So, actually, a vertical line has an undefined slope. And we can't write vertical lines using slope-intercept form because they, well, what are you going to write? Y equals undefined x? No, you can't. You just can't use that format. There is a way to write equations like that. They're always what? X equals some constant, but that's a special case. All right. Interesting. I see all my lines on that grid. They show up fine on my monitor. I see they don't on yours. I actually have all these lines on mine for the resolution. Okay. So negative 1/6. In general, what should this line look like? Tell me a little bit based on what yeah, it should be going downhill from left to right. All right, so how do I do this, negative 1/6? What do I do? Well, remember, the top of the fraction is change in y. The bottom of the fraction is change in x. So it's kind of like this. If we start at the old point and go down 1 and to the right 6, won't that give me a downhill line? So if I go down 1 and to the right 6, can you see? And that's how I would do it. Or, by the way, I could go down 2 and to the right 12. Can't I use any fraction that's equal to negative 1/6? And the answer is yes. And by the way, I don't have enough space here. I don't have 12 notches to the right, so I won't do it. But sometimes that's a really good idea. Because if you get your points too close together, what happens when you try to connect them? It's easier to connect 2 points that are further apart, isn't it? So a good piece of advice is if you have a tiny fraction and you got a fairly big grid, go to an unsimplified version of the same fraction, like 2/12 or 3/18. In this case, I don't quite have that many notches, so I'm going to go down 1 and to the right 6. We'll put another dot. Then just take out the old straight edge. I have kind of a different straight edge up here. Anyway, you should stick a couple arrowheads on the end because you want to emphasize, that this line goes on forever in both directions. Okay, it's literally never stops. Okay, does that look familiar to everybody? Probably. Okay, now let's do one backwards. This time, even though that's an incredibly ugly and sloppy line, we're going to take I'll tell you what, let me just start with a new one. So I'm going to put a line on here, and this time the goal is, can you find the equation? So kind of go backwards from graph to equation. Okay, so here we go. Now let me stretch it out a little bit. Okay, what do you think? For an equation, how could you get an equation? You know, we know we're headed for this. We want something to fit this. What do you think we should do first? It's not as important what you do first, but I would do the y-intercept first, wouldn't you? I mean, try to find, and in this case, I tried to set it up so, well, you can't see the grid. I apologize for that. It turns out to be the second notch up. So doesn't that tell me this? Okay. And then, again, I know, sorry, my grid does, what I'm going to have to do is use the base grid underneath it. I will next time. So what you got to do is just do what you want to do is find another crossing point. On my graph, I can see that this is crossing the x-axis right there, and I can see that that's 1, 2, 3, 4 to the left, and it's also 2 down. So it's like 2 down and 4 to the left. Do you see why I made them both negative? 2 down and 4 to the left. On a graph, down is negative and left is negative, right? And what happens when you divide negative 2 by negative 4? You get a positive 1/2. So that must be the equation then. Okay, so you ought to be able to go both ways like that. Yes?
When determining the slope, is it alright to work from the point on the x-axis to put the slope versus working from the point on the y-axis?
You can pick any two. What you want to do is try to pick 2 grid points where it crosses as close as possible to, so you don't have to mess with fractions. It doesn't matter which 2 points you pick. And then you could actually use the slope formula and just do change in y over change in x. Since I usually like to start with the y-intercept, that usually is a place I like to begin, but you could begin anywhere. Okay, I'm assuming that looks pretty familiar. All right, for our next little exercise, here's what I'd like to do. This time you'll notice I gave you a point and the equation of a line. Okay, so point, 4, -2, line equation, y equals 2x minus 1. Part A, we want to find the equation of a line that is parallel to that guy and goes through that point. In part B, we want to find the equation of a line that is perpendicular to that guy and goes through that point. So now, quick review. I haven't told you this yet. Well, I think we said it sometime. If 2 lines are parallel, their slopes have to be equal. Yeah, we talked about this last time. And if 2 lines are perpendicular, their slopes have to be upside down on the opposite sign, right? So I usually say negative reciprocals. So opposite sign and flipped upside down. All right, so let's go at it. So part A, we want the equation of a line that's parallel to this guy and goes through this point. Well, what's the slope of this guy? It's actually staring you right in the face, isn't it? Isn't it 2? This is our m. So what's the slope of our line? It's got to be the same. So now we already know this much. Don't we? We already know the slope. We just don't know the y-intercept. So again, we'll let that be just b. And now, what do you think we're going to do to find b? We only have one point this time. That's what we're going to substitute in. So we're going to plug in a -2 for y, a 4 for x, and that should real easily allow us to solve for b. So what do we have? -2 equals 8 plus b. And when you subtract 8 from both sides, what do you get for b? Yep, -10. So now all I got to do is come back here, rewrite it with a -10 in place of b. You can either say plus a -10 or -10. I'm fine with both. There it is, the equation of our line that's parallel and goes through the point 4, -2. Okay, part B. Let's find the equation of a line perpendicular to this guy and going through this point. Well, once again, I keep calling this guy. The slope of this guy was 2. So what's the slope of a line perpendicular to it? 1/2 negative, right? -1/2. So right off the bat, we already know this much. We took the negative reciprocal slope. Okay, now all I got to do is find b. And I only have one point, so this is not too hard to decide. I have to plug this point in again. -2 for y. 4 for x. And this time, what happens with b? Yeah, b comes out to 0. So coming back up here, what's the equation of our perpendicular line? You could just say -1/2 x or -1/2 x plus 0. Yes? Okay. I realized I didn't write a whole lot down here, but the part B was supposed to be to take the original equation, find a line that's perpendicular to it. Okay, rule. Slopes of perpendicular lines are negative reciprocals of each other. Since I already know the slope of this line was 2, I flipped that upside down and changed the sign, and that's where I get the -1/2. Other questions? So these are kind of typical problems in this type section. Should we move on? Okay. This one's kind of modeled after, this is number 92, so let's actually go into the assignment, take a look at it. Now, yeah, and I'm glad we're doing this because you'll notice the directions already kind of violate what I said. It says, write the slope, no, it's fine. It says, write the slope-intercept form of the equations of the lines that go through the given point. Oh yeah, and part A is parallel to the given line, and in part B, so it's just like the one we just did. Okay? Now, that's a different equation of a line. What's going on there? Y equals 1. Where's my mx plus b? Actually, you could think of it as being there, couldn't you? Could somebody re-say this so it's got an x and a b in it? Couldn't you think of it that way? It's like no x plus 1. Okay, now you can see more clearly what's true of this line. It has a slope of 0 and a y-intercept of 1. Okay, so part A. What's the equation of a line parallel to this line that goes through this point? Well, what's the slope of our original line? 0. So what's the slope of our line? Because we're parallel to it. It's got to be 0. So already we know, and I'm just going to write it this way for right now. Already we know this much, don't we? Our slope has to be the same. And now, same old thing, plug in the point. Do the arithmetic. Very simple arithmetic in this case, isn't it? It's pretty clear that b has to be a -2. Okay, so come up here and rewrite this now. How can I write y equals 0x plus a -2? I could write it that way, or couldn't I just say, because what's 0x? 0 anything is 0, and I can just ignore it in an addition problem. Okay, part B. This time we're doing that's the parallel symbol. Part B, we're doing the perpendicular part. This time, find the equation of a line perpendicular to this guy and going through this point. Now, we got a problem here. What kind of a line has a slope of 0? Remind me. Horizontal, right? 0. So perpendicular to that, I got to take the negative reciprocal of 0. So I got to put 0 down in the denominator. Ooh, I can't do that. Yeah, it's undefined. And what's going to happen? But tell me now, just on the basis of geometry, where is the line? What kind of line would be perpendicular to a horizontal line? A vertical line, yeah. Now, the only problem with vertical lines is they can't be written in slope-intercept form because they have an undefined slope. But how can they all be written? X equals some number. So actually, they're not such bad guys to deal with. They just don't work in slope-intercept form. Okay? So in other words, it's just x equals something. X equals what? Take a look at the x-coordinate of the point we're supposed to go to. We're done. X equals 4. So that's kind of a unique one. We couldn't use our technique there, could we? So, write yourself a note that all vertical lines will be in the form x equals some constant. Like x equals k, or some letter to represent any number. So x equals -2,344 is a vertical line that crosses the x-axis at -2,334. And x equals 19 is a vertical line that crosses the x-axis at 19. And ours is a vertical line crossing the x-axis at 4. Ready to move on, or does anybody have a question? All right. Now, this is a problem like number 84. I switched it around just a little bit. So this is unique. Instead of giving you 2 points in a normal way, they said, we're going to give you the x-intercept and the y-intercept. Can you find the equation of the line? And the answer is, yes, we can. So here, I'm telling you the x-intercept is 2/3, 0, and the y-intercept is 0, -2. Can you find the line? The equation. And anytime you have 2 points, you can find the line. Remember, step 1, find the slope, and then plug that in and solve, So let's go. What's the slope here? All right, let's make a decision. Let's ask somebody else here. Melody, which point of these two should we call 1, and which point should we call 2? It doesn't make any difference which one you pick. Oh, no, not that one. I'm joking. That was a terrible joke. I just got to tell you, I tutored a young man when I was teaching at Charlotte Lutheran High School. I had a young man in class who he had cancer at an early age, and it was in his head, and he had to have radiation done. Anyway, the radiation got rid of the cancer. The bad news is he lost almost all of his vision. So anyway, he had special technology, and he had to put his face really close to the screen that blew things up quite a bit. Anyway, I wound up tutoring him, and boy, he was the nicest kid. I really loved working with him. And when we were tutoring, to kind of lighten things up, I would play little tricks like this, and I would say, okay, pick a number, any number you want, David. And he'd say 7. I'd say, oh no, not that one. And he would laugh. Okay, and that's where that happened, so I apologize. So anyway, Melody, the top one is which one? 1 or 2? Excellent choice, just excellent. Okay, step 1, find the slope. Hopefully you got this baby memorized now. You want to be able to come out with that very quickly. All right, using Melody's labeling, we would take y from point 2, subtract the y from point 1, put that over the x-coordinate from point 2 minus the x-coordinate from point 1. Then just simplify. Negative 2 minus nothing is negative 2. 0 minus 2/3 is negative 2/3. Okay, we need, first of all, it's a negative divided by a negative, so we know it's going to be positive. And how can I do that? Can't I just invert the bottom fraction and multiply? So isn't it really 2 times 3 over 2? And the 2's will cancel. Okay, so we got a slope of 3. Therefore, when we try to move into this important slope-intercept form, we now know m. And so let's stick it in there. We just literally took our 3 and put it in place of m. Now what? You have 2 points now. Pick one of the 2, plug it in. Let's take the top one. It'll work real nicely. So I'm going to take this point and plug it in. 0 equals 3 times 2/3 plus b. And what happens when you multiply 3 times 2/3? 3's cancel, you get 2. And so it should be pretty clear that doesn't b have to be negative 2? So just finish writing the equation now. I don't know why I put that so high. Okay, so just a little bit different. Sometimes they'll just give you intercepts, and sometimes they won't even tell you what the coordinates are. You got to, in your brain, go, well, let's see, if it's an x-intercept, then the y-coordinate has to be 0. So, okay, next. Questions, anybody? All right, let's take a look at number 96. This is another one of them. This one I already did. We'll just kind of look at it and see if it looks right this time. So this time they gave us a decimal point, negative 3.9, negative 1.4. And look at the equation they gave us. 6x plus 2y equals 9. Ooh, it's not in the right format. Did you notice that? I don't see any mx plus b. So the first thing I really needed to do is up there in the top right. I simply needed to solve it for y so that I can see the mx plus b. So a little bit of simple algebra gets me down to here. Now can you see the slope? Yeah, there he is right there. And there's your y-intercept. So now we know what's going on. Now, can you give me the equation of a line parallel to that line that goes through that point? Sure, I know what the slope is, so I can just copy that. Now all I gotta do is find B. Now it's an old story that we have done already repeatedly today. Pick your point. We only have one point. Plug it in. Solve. Well done. Any questions? So while I'm not real thrilled with decimal problems, there might be a couple like that. Okay. Let's take a look at number 102. Okay, number 102 says find a relationship between x and y such that x comma y is equidistant from the 2 points. So in other words, they gave you 2 points, and they want you, so it's like, here, I'm going to just make a quick sketch up here. So they like gave you 2 points, and they want you to find all these x, y points that are equidistant. And you should get a set of points, an infinite number of points that looks something like that, because you remember from geometry class, all points equidistant from 2 points. Aren't you going to get a perpendicular? Really what it is, it's all the points that lie on the perpendicular bisector. Okay, so what should we get for an answer? We should get a good old straight line, something in y equals mx plus b form. Okay. Now, how do we do this equidistance thing? Answer, the distance formula. Okay, I just put it up there to remind you. All right, so take xy and set up the distance with the first point. And that's what I wrote right here. Right, I just, and then set up the distance from xy to the second point, and that's what I put right here. By the way, do you see why this is a plus here? Because doesn't the distance formula say x2 minus x1? Well, what is y minus a negative 8? Doesn't that become plus 8? Okay, I just want to make sure you see what I'm doing there. All right, so I got one big old square root equal to another big old square root. This is good news, because they're single square roots. Can't I just happily square both sides and get rid of all square roots of it? Answer, yes. So if you want to put a note on this line, put a big smiling face, because we got rid of the square root signs. Okay. Now, just a little bit of algebra 1. I got to basically square all those wonderful things and get what? 4 ding ding dingers. So I did that. And then start getting rid of things. I have an x squared on both sides, so I crossed those out. I have a y squared on both sides. I happily undid those. I combined things, and that brought me down to here. And then I just got y by itself, divided both sides by negative 26. You know, maybe it's not real pretty, but there it is. I can see m and I can see b. And once you know m and b, you know everything there is to know about this line. So here, this is an interesting problem in that it ties back into something we had earlier this semester, the distance formula, and yet it's a problem about straight lines. You have your hand up back there, Emily?
So after you do this ruler, you like a handshaking?
After I squared both sides,
Yeah.
yeah, then I hand shook all these out 4 times. There's a lot of horsing around. And then it gives you all these terms, and then basically it was just trying to get rid of things, trying to combine terms. Does the strategy of the problem make sense to you? I think that's the most important thing here. Good, because what I need you to be able to understand. Okay, let's take a look at, let's just take a peek at number 110. Okay, now here's one of the word problems, and we'll show you how this fits into a, this section. A school district purchases a high-volume printer, copier, and scanner for $25,000. After 10 years, the equipment will have to be replaced. Its value at that time is expected to be only $2,000. As you know, there is this terrible thing called depreciation, right? Yeah. There are a few things that actually gain in value as they get older, but not very many. But, like if you really keep, for example, an automobile in mint condition, sometimes it can really rise in value later on. But otherwise, if you don't really take special care, unfortunately, everything goes this way when it comes to the value. So this copier goes downhill in price, is worth $2,000. Okay, so the question is, write a linear equation giving the value of V for the equipment during the 10 years it will be in use. Well, this one may puzzle you a little bit, but really, isn't that saying, after no years, in other words, right after you bought it, how much is it worth? $25,000. After 10 years, this is what it's going to be worth. Well, aren't those just like ordered pairs? Yeah. Okay, now you know what to do. How do you take two ordered pairs and make the equation of a line out of it? Step one, find the slope. Okay, let's go through the slope. I call this one on the bottom 0.2 and the one on the top 0.1. So y2, 2,000 minus y1, 25,000 over 10 minus 0. And I got negative 23,000 over 10, which is negative 2,300. There's my slope. So, good old mx plus b. I stuck this slope in place of m. And now all I got to do is find b. How do I do that? By the way, on this one, I don't even need to calculate because isn't the y-intercept even already shown up in the top right corner? Isn't the y-intercept the 0, comma, whatever? So we had it handed to us. It's 25,000. So when they hand it to you, again, you should smile first and then write it down. Maybe just do a little inner, oh, thank you, book, or whatever, or even better, oh, thank you, God. All right. Questions on that one? Now, all of this stuff should be pretty familiar to you. So, here's what I've got down for the assignment. We're going to go back to the old every other odd. Now, there's quite a list here. It goes all the way up to 137. But you're doing every other odd, so that means what? 1/4 of the problems. So, what is that? 68? It's about 34 problems altogether. So what I'm going to, if you want to get going, you can. If you want to stick around, we still have 5 minutes. And if you'd like to work on things, I'll be happy to walk through and help. Have a good day.